So I'll be talking about a bit of a combination of design and computer science. My background was in sort of a mix of both. I started fairly young. I had always pursued them as sort of separate disciplines that I did my first logo for my school when I was about 11 or 12 years old, and I around the same time sold a really embarrassing little piece of software, like a little game or something like that. And I had never really seen how to mix things properly, and I had always thought that, you know, perhaps the right combination was going to be something around interface design, you know, sort of how can I try and use my background for good. As it turned out, I worked as an interface designer for a couple of years and really wasn't very fulfilled by that it just didn't quite mesh. And you know, shortly after finishing that work, I went to the media lab at MIT and joined this group, the Aesthetics and Computation group, where everyone had some sort of background in some aspect of the arts plus some aspect of engineering or the sciences. And one of the first projects I did when I was there was you know, trying to get this interface design thing kind of out of my system. And you know, you're always trying to help the user and you know, make things easier for them. And instead I wanted to make something that you know, this is sort of an antagonistic painting program. You know, so here it's going and trying to straighten your lines out instead of letting you do curves. This one kind of drawing opposite of what you actually want. Here we're instead erasing as we're going through. So basically, you know, can we actually make something that's anti-user? So this one kind of wants to huddle together, and not a very effective way to actually do any drawing. After that, really what I was interested in is information design and data visualization, and really how can I, as a designer, try and work on or work with data sets that are much larger than what I can do, you know, just by hand instead of sitting down with Adobe Illustrator and fighting through things. This is what data looks like when we start out, and so it's this and more of this and something like this. This is going to be a great talk, huh? We're going to look at spreadsheets. And instead what you're trying to do is take all of that and turn it into something that's actually engaging and that can explain to people what's actually in that data set, how it works, what's interesting about it, really trying to pull kind of a story out of it. And so, for instance, this is based on a set of UN population data, so the population for the last 60 years, and then also population prospects for the next 40. And this was done for a client where they were focusing on this aspect of you know, what happens as populations age, and in particular with Japan. So this is men age 0 to 4, 5 to 9, 10 to 14, and so on up through age 100, women here, and basically how many people within each of those age groups. And so here in 2010, Japan has this cohort of people that are, you know, age 60 to 64, and what happens when they start all aging. As they're aging, that you're going to have this enormous population that has a huge impact on healthcare, on the economy, you know, sort of what's actually happening there. We can also interact with it. So here, looking forward, this is what that's going to look like over time, up towards 2050. Over at the right-hand side, we have a more sort of, you know, qualitative look. This is superimposing the, you know, Japan and the U.S., and we can see that the rise of Japan actually is kind of opposite the population booms in the US. We can look at other countries here, and then along with that, actually go through and just play all that back. So this is population going from 1950 to 2050, and just being able to get a sense of what's actually in there. Another project, sometimes we're trying to take information and turn it into something that people can, actually want to interact with. So this was a piece looking at a survey that was done in Saudi Arabia based on healthcare attitudes. So let's see, my overall health is fair. My weight is a bit above ideal. I've been here all week. And I've been okay about eating. And what happens is, and then we get back, these are the percentages for how everybody else has actually answered the survey, and I can, show just men, just women, just certain age groups, things like that, or viewing all. But also because this was for Saudi Arabia, we actually had to do the interface in Arabic as well. And this presented sort of an interesting challenge because, we knew that, okay, so the, writing where everything's going to be right to left, but as it turns out, all of the interface elements actually have to go right to left as well. So poor, fair, good, excellent instead needs to go poor, fair, good, excellent. And so we had to have a way to reorient everything. And so here we switch over to Arabic. The interface can switch itself around completely. We can switch back to English and so on. And this plays out across, we have just different ways of showing each type of data. So I choose what I eat because it's convenient, it's filling, and it's tasty. And then here's the results for the rest of the survey. We can do the, some of the others, what we drink. Be able to select just how much Arabic coffee I drink in the average week. Diet drinks, hot chocolate, and then comparing that against everyone else. So trying to turn this into something that was fun and that people enjoyed, and also, took in the results and then was able to show it further. Sometimes data is just interesting to plot out and just see it, just to see what's actually inside that, inside the information. This is the entire United States actually just designed as a map made of nothing but roads. I haven't added any actual geographic features to it. This is simply plotting out millions and millions of road segments across the entire US. The wonderful thing that happens is how it follows the geography. So, the basic thing we have, in different areas where there are cities. So here's Chicago, Detroit, Ann Arbor here in Michigan where I grew up. The Midwest, things are fairly gridded out, a little bit more open. Here's California, so the left-hand side there, that really dark area is the Bay Area. And then as you head east, it gets all a bit messier as you head into the mountains. But this here is really wonderful. So this is the Appalachian Mountains, and it basically pops out of the data based on how the roads actually avoid the mountains. And so nothing is actually done to get the topography in there or actually have any sort of image of what it looks like, but instead it just comes directly out of the data. And it's one of those things where it's sort of nice and fortuitous when a data set actually does that. We also were asked to do a large-scale version of this for an installation in Frankfurt in order to see if it was going to work. It's all about sort of getting the line weight right. We had just moved into a new studio, and we wanted to actually print it out and kind of see, are the line weights actually going to work? This was also a couple months into my, having staff for the first time, and so my poor staff, we actually went and assembled the entire map. So here's Chris and Katie working extremely hard, putting the map together out of 399 sheets of 8.5 by 11 paper. In the middle, the printer broke down, so everybody had to take an internet break. We can also sort of watch the light changing across the studio during the day, and they're back to work. And so this was, fairly interesting just to see this all kind of laid out and actually working and be able to verify, what it all looked like. And luckily, they didn't kill me. There's Chris doing the last finishing touches, and then it kind of comes out like that in the end. A lot of my work has dealt with genetic data, so because I can't do street maps and get a degree out of it. So my PhD work in particular focused on understanding what's in the human genome. And so, human genome, it's 3.1 billion letters of genetic code, these A's and C's and G's and T's. And as I was learning about this, I actually, I hadn't taken any biology classes in undergrad because I was studying design. And so I would sit in classes in grad school and sort of, they say things like, well, it's 97% of the data is not actually used, and 3% is coding, and so I start kind of daydreaming about, what does this actually look like? And so I wanted to have kind of a poster of, 50 million letters from a chromosome, and what does it, look like just kind of printed out. And instead, so in order to start this, how do you look at 3 billion letters? You begin with a very small font. So we take this 3-pixel font, these A's CGT letters, and just color them based on the material that's actually coding versus not coding. And then I had an opportunity to show that, this as part of the Design Elastic Mind exhibition. This is all of chromosome 18, which is about 72 million letters, just printed up on the wall like this, sort of wallpapered directly on. The coding portions are shown in color. This is what it looks like a bit up close. You can see sort of the texture on the wall and what that comes out like. I was really excited because when the exhibition was written up, the New York Times had sort of a slideshow about it, and this was the lead slide, and I was like, oh, fantastic! Like my work is actually mentioned in the New York Times, and actually it wasn't my work at all. It was all about the type that was on top of my work as the introduction, and so that got me curious about other people attending the show, and so here's some other folks, sort of digging through Google Images, also attending. So this was one of the most popular pieces in the show, yet it wasn't actually popular for the piece itself. Here's some other folks who attended. Another guy who had a really terrific time. I spent a lot of time working with scientists at MIT trying to find better ways of looking at the data that they work with and that they deal with. This was a diagram that they had produced that looks at how different structures are actually found within the data, that certain letters within the genome kind of group together a bit. This was a tool that they built to actually analyze that type of data. This is a redesigned version that I did of it. Even just doing very basic graphic design things of cleaning up the color and the typography and removing the extraneous information that wasn't actually useful, or not having the genome going at a 45-degree angle and instead having it just read kind of right to left or left to right like that. And even this was kind of a bit odd and controversial for them. There are other representations of the same data. So this is same data set shown a different way. This one looks a little bit more mathy. Some people preferred this. Mathy is real. It's good. So it's we can't quite understand it. So it must be correct. Folks are more comfortable with that. This was a more qualitative way of looking at it. And really, we're talking about the same thing across all of these different data sets. And so instead, I said, well, what if we start with this more qualitative way of looking at it and integrate that with all of these other representations. And so here, starting with a more qualitative look, this is that original diagram that I showed, just laid out. There's various ways of looking at it. I can, so these gray bars here are transitions between these different block setups. If I want to get a closer look at that, I move over into 3D. This is kind of a waste of an additional dimension, so I can actually put extra data into that z-axis. And, so that's this data here. And having done that, if I look at it directly from the top, I get exactly that plot. And so I can actually, move back and forth between these different ways of looking at the information and say, are we really just kind of all talking about the same thing? What does it actually mean? We also use that as a cover for the journal Nature with a more, sort of complicated version looking at different populations or groups. And that kind of gets into this issue that I run into a lot with this work, that there's sort of this battle of, aesthetics and function. They're these brothers that hate each other, sort of Cain and Abel style. And typically within, the scientific work especially, that, how people actually, respond to it, if it's too pretty. So for instance, the redesign that I showed, I actually had one of the scientists tell me, it's too pretty, I don't feel like I'm doing science anymore. And so she was actually quite leery of actually using the software. But then after a week or two, people wouldn't actually, refuse to go back to the older version. Rarely is it, sort of one versus the other. Maybe it's kind of a spectrum. You can take a little bit of each and try and get a sort of balance. I don't like that because it's actually implies that, aesthetics and function wind up being this sort of mutually exclusive thing. Instead, maybe is a kind of a spectrum where it's, a bit more of the aesthetics and a bit more of the function, and just kind of wherever you are on that scale. In reality, though, like, those are never the axes that are really have the greatest influence on any of the work that you're doing. And so, it's all about the time you have to do it, the actual audience you're trying to address, the context in which it's going to be used, and, sunspots. There's just all manner of influences on things. Switching over, you have something like this, where this was done as a installation piece that just shows how the biologist version of Google works. And so they take enormous sequences of ACGT letters, put them in a database, and this just is a representation of how you do running an actual search. And down at the bottom, I can run through a search, and so that's the darker line going through there. And so this was more of a just done as a installation thing, trying to get people sort of get their curiosity going a little bit more. Also for that project, we use this ACGT keyboard, which the most sophisticated way to sort of create all of the universe in 6 days and have the 7th to rest and all that. This one also made it into the movie The Hulk. So it turns out you can actually take DNA and put it on a scanner and scan it into your computer and begin doing genetic analysis. So as mentioned in the introduction, one of the other projects that I spent a great deal of my time on is this thing called processing. It's a free and open source programming environment. It's about making it easy as possible to make visual things. So it's free and open source and it works on Mac and Windows and Linux. It's at processing.org, and we're just trying to get more people to think about using computation in their work. So get more designers doing programming, get more programmers doing thinking about art and design and so on. Casey Reese and I are the people who started the project, and then there's been this amazing community that's grown and really built things around it, and the project just continues to grow. So this is the number of users every 4 weeks or something like that since 2005 or so. One of the wonderful things about this graph is that it turns out nobody actually likes to code over Christmas, and so there's this drop every time we get to the holidays. Thankfully people are instead spending time with their families. Also, things in summer, things kind of trail off a little bit as we head into the holidays and sort of the August months, at least for the Northern Hemisphere. And so I'd like to show a couple of projects quickly about things that people have done with the processing software. One of the things that we try and focus on a great deal is this idea of sketching. So too often what happens with programming is that you kind of try and sit down and think through a program and think deep thoughts and solve big problems, and then you kind of make this program. And instead, we actually want it to be more like sketching in a sketchbook, and so not be too precious about code, get a little bit down, and see what happens. And so Robert Hodgin did a series of works. Here he starts with a very simple sketch. This was he was interested in playing with magnetism, and so he kind of worked out a bit of math to be able to look at that. He then went and took these individual points and started wiring that up with analyzing audio, and so now each of these dots are kind of responding to different frequencies in the audio. And then his mom made a quilt of it, which is also kind of great. So his mom has this a really terrific eye and actually kind of fixed all the colors just slightly, and the composition is just a little bit better than his original. And then the final this piece eventually then evolved into what became the iTunes visualizer. So Apple actually acquired the software. They ported it all over to C++ and OpenGL and sort of did a version that they could actually ship. And actually now, at this point, Robert's not even using processing. He's actually moved on to being a C++ developer and building his own framework with another friend of his. And Robert started as a sculptor at the Rhode Island School of Design, which is really kind of cool and kind of goes to this mission statement that we've developed over time. So the processing project seeks to ruin the careers of talented designers by tempting them away from their usual tools and into the world of programming and computation. Similarly, the project is designed to turn engineers and computer scientists to less gainful employment as artists and designers. And so to the extent that we can actually encourage that kind of behavior, it's really a wonderful success, and it's so fun sort of seeing people evolve from, sort of moving one direction or the other, or, simply augmenting their skills and becoming more literate with it. Another type of work that we particularly enjoy is, when you get off the screen and actually doing things in real life. This is a piece called Green Cloud from the artist group Hee. They actually took a live data feed from a local power plant and then hooked that up to a piece of processing software that drove a laser beamer to project a cloud onto the actual smokestack, the cloud, the pollution coming out of the power plant itself. And then they just changed that in proportion to how much energy was being produced at that given time. And so there's something wonderful about, this doesn't exist on the computer. Instead, it's actually out there in real life. Anybody in the town can actually understand this because, based on how people are using energy, you see the cloud gets, larger and smaller. It's a pretty straightforward kind of idea. And then they were able to use this to kind of set up events around, trying to limit use, so people could actually see the cloud changing in size significantly as they staged events to get people to turn their lights off and things like that. So that's what it looks like a bit from a distance there. So again, just the nice thing of getting off the screen and out into the real world. Nervous System is a small company by Jessica Rosenkrantz and Jesse Louis Rosenberg. They make bio-inspired jewelry. So basically, writing software uses math to sort of figure out what these forms should look like, and then they take that, send it off to a laser cutter, water jet cutter, whatever, and produce these beautiful jewelry works from that. And so, using mixing computation and the art of it and being able to produce these wonderful sort of things with it. Another thing they do is they create tools that actually supports the creation of their actual, the things that they sell. This is another thing that I'm particularly interested with processing, is that we're trying to get people to be less comfortable or less happy with the tools that they're forced to use. That with Adobe Creative Suite, with Photoshop and Illustrator, we kind of have the Microsoft Office of the design world, and then it's equally as generic and horrible and expensive and whatever. And I'm not interested in people, sort of making the next Photoshop or emulating that, but I am really interested in, how do you get people to say, well, that doesn't do quite what I want it to, but I want this thing that's actually going to let me create these jewelry things that I have in my head, and I want to be able to have these different parameters for it and such. And so it's exciting when we see people kind of using processing not as a thing unto itself, but rather something that kind of gets a designer or artist a little bit further along in their actual process. And then this is the form based on what was just created there. Switching back to my own work, this is looking at Charles Darwin's On the Origin of Species book. There's been a lot of Darwin talk this week. One of the things I became interested in was a friend of mine who studied evolutionary genetics was telling me about the fact that his book actually changed significantly over time. It actually went from about 150,000 letters, 150,000 words in the initial edition, and progressed on to being about 185,000 words by the time he wrote the sixth edition. So that's a really significant change, and also that because we have all these editions, we can actually see what that looks like. And so it's fascinating about this idea of, that typically, especially outside of science, you think of scientific ideas as being these sort of fixed things. Like Darwin kind of went off on a mountain and came down with a theory of evolution on clay tablets, and that was it. And then Darwin died, and here we are 150 years later. But instead, here, over 13 years, he was really kind of struggling with this idea and trying to figure out what was actually happening, and that because he published these multiple editions, we can actually see what that looked like and understand how things changed over time. So the first thing I did was made a piece of software that just takes all 6 editions. Over the left-hand side, you have sort of smaller Greek versions of each text. So first edition is the shortest, 6th edition there on the right is the longest. Blue means an addition, red means a deletion. I can zoom into a particular column, and we can actually read the text there. And essentially what we have now is, this is Darwin plus track changes. So here's Darwin sitting down with Word and trying to figure out, it's like, well, maybe it's not really very slight deviations, maybe it's just slight deviations. And so there's this range of, sometimes he's kind of increasing or decreasing emphasis. Sometimes he's, completely changing or introducing a new idea that, survival of the fittest we actually attribute to Darwin and his theory. It was actually Herbert Spencer, and it didn't actually show up until the 5th edition of Darwin's book. And so there's a lot of, shifts like that happened within the text over time. The final piece simply showed a composite of all of those books, and basically, so here's the preface over on the left-hand side, things sort of Greeked in, and over time, this simply adds each edition in turn. And so we'll be building out an image of the entire book. With the mouse, I can actually see what the text was in a given point. And the types of things we see, so here in the very last paragraph, in the 2nd edition, he adds this reference to God. So first he said, there's grandeur in this view of life with its several powers having been originally breathed into a few forms or into one. And instead he's, sort of hedging a little bit on the whole God thing, having been originally breathed by the Creator into a few forms or into one. So, taking on the scientific establishment and the religious establishment at the same time, maybe let's hedge a little. But what we can do here is just, see how the book itself built out. So 2nd edition in orange, 3rd in green, 4th in purple, 5th in blue, and so on. And, so sometimes you'll see things contracting, sometimes the additions being added. As we get to the next edition, we'll see the 6th edition where he actually comes through and, perhaps feeling a bit of his own mortality, realizing that he needed to sort of more directly address some of the concerns about the theory, and sort of people taking potshots at him in the scientific community. And so here he goes through and he's going to add a new chapter to the center that just deals with criticisms of the theory. He excises that from all of the other chapters, so you see all the other chapters kind of shrinking, and then there's the new one. And so basically just being able to see, now I can zoom in, see exactly where each of these bits of text came from, and so on. And I wanted to finish with some student work. I was really inspired by the student Pechakucha talks, and so I wanted to show 3 projects very quickly from a course that I taught with Golan Levin at Carnegie Mellon University. We were looking at data visualization, information design, be able to get people thinking about data in different ways. The first one is this handwriting piece by student Aicha. Aicha actually kept a journal ever since she was about 8 years old. And so for this project, she went and took one page from the month of May out of the journal from every single year during which she'd actually kept it. Having taken that, she scanned it in, and excised just the descriptive words, from each of the bits of text. So a lot of really nice things happening here. So, when she's going through more dramatic periods in her life, a lot more words being used. Also, just as she gets older, we can see changes in her handwriting and how she's, sort of looking at things. So here, this is the year she learns, cursive, and she's using words like, really, and cute, and like, and cute, and, then she's getting a little edgier, and then now she's getting a lot edgier, screw cursive, I'm doing all caps. And then we don't actually even need the ages because, then we get to this, this year where the page reads, never, messed up, weird, hate, bad, depressed, sucks, sucks, sucks. So can you guess what age she was? Later, starting graduate school, here going through a breakup at the time, and just this really wonderful, non-computational way of looking at this really interesting set of data that's very, very personal and also, says a lot about sort of what she was, this overview of what was happening in her life. Laurel Bancroft, she was a sophomore, I believe, in the art school. Carnegie Mellon has this fence where students actually go and they paint different messages on it, advertising events, fraternity parties, whatever. In this case, they're geeks, and so they're actually advertising a programming language event or party or something like that. And so over time, this has gone on for, this particular fence has been up for about 14 years. And so it's this amazing, sort of just layers and layers and layers of paint. And so Laurel went and actually took a core sample of it. And so this is what it looks like. This is about 1.5 inches to 2 inches long with just all of these layers of paint. And so Golden and I loved this. We were really excited about it and said, well, great, but you're going to have to be more scientific about it. Like, what would you actually use to take a real core sample? And so, it turns out it's go and get a jeweler's saw, actually take a proper sample, see if you can get a good, clear version of it. So here she has to write up a permission form to get permission to actually go and take a core sample of the fence for All in the Name of Art. Run that by the police, the faculty, facilities manager, the department representative, the assistant vice president, of the director of environmental health and safety, and so on. Luckily, they all approve, and so this is the result. So this is 609 layers of paint from this amazing core sample of 14 years. And there are all these wonderful sort of stories embedded in it. Down at the bottom, so this is the oldest part. At the time, the housing office would actually give out paint if you wanted to paint your dorm room. And so a lot of students said, hey, I need to paint my dorm room. So that's why we have all these very generic things. About a year's worth up, the facilities folks got wise that people actually weren't using it for their dorm room. They were using it to paint the fence. So then the colors get a lot more interesting after that. The middle section, that's wax from right after September 11th, 2001. And that they had a candlelight visual at the fence. Up here, a section where people actually attached AstroTurf to the fence, and so things a bit more interesting, and so on. But just this wonderful thing of being able to take something so simple as just this core sample, but have all these wonderful sort of stories embedded into it. And this is the final print, and she also had a sort of magnifying glass there for the final piece. And then I'll finish up with, this is Rebecca Hume, who is a graduate design student, looking into the truth about cats and dogs. And so this age-old question of, what's better, cats or dogs? And so she wanted to find, some sort of experts that could actually weigh in on this. And so she went and contacted Nobel laureates, because they're experts, like they smart, know everything. And the wonderful thing is that they actually all wrote back, or a large number of them wrote back. And so it turns out dogs went out a bit, cats a little less so, but it's not terribly conclusive. Yet the really interesting thing about these about the sort of data collection of it is not so much the cats versus dogs, but rather how people actually talk about their pets. So here's Edmund S. Phelps, who won the Nobel Prize for Economics in 2006. My wife and I are longtime dog lovers, although our dog died after years of putting out warmth and humor. I am horrified to think that some Nobel laureates may harbor cats. Some others get a bit more exotic. Bob Horvitz had the pleasure of taking a genetics course with him. He won for medicine in 2002. Current household pets, 2 dogs, Coco and Lizzie, just lost a 3rd star, 1 bearded dragon, Pogo, lots of tropical fish. Just a really wonderful range to it. And then finally, perhaps my favorite, Leon Letterman, who won for the prize for physics in 1998. We have a very intelligent standard poodle, Toby, 2 rather pleasant, accommodating, but dumb horses. I'm not sure who expects their horses to be smart, maybe just Nobel laureates. There was once a great barn cat, but it disappeared. Are you sure you can't find something that challenges you more? With that, thank you very much.